Today we're going to explore slope, it's not soap, slope with similar triangles, okay? We can compare two triangles that are similar on a line, and when you put two similar triangles on a line, they will contain the same slope. But let's prove this, okay? We've got two triangles on this line, and I've been having you draw these triangles already when you find slope. So this should be very easy for you to recognize and very easy for you to count and figure out. But I'm going to highlight my two triangles with two different colors just so you can see them. All right. My two triangles. The first thing I do when I count slope is what? Yes, I'm going to decide whether it's negative or positive. You are correct. So I know somebody was thinking that out there somewhere. All right. So this line is going up from left to right, which means it's positive. So I'm going to not put a negative sign over here. And if you notice, when I have you drawing these triangles, they actually make a right triangle. Okay, and some of you may have recognized that and some of you may not. And the way we know they are right triangles because we can draw a angle in the corner, and that angle has it's kind of like the corner of a square. And if you notice, this looks like the corner of a square. That is a right angle. The other sides of the triangle, I really can't do that and make it look like a square. So that's how we know where the right angle is on a right triangle. I know. Here we go. So the first triangle I'm going to count is this one right here, this little green one. And I'm going to count the rise and then the run because that's how we find slope on the line of a line on a graph. You could use your points, but I find that most students do much better with rise over run. If you used your points, you would use the formula that we've been using for the last couple of days, but then you'd have to name your points, and that just gets into a whole nother mess. So we're just going to do rise over run. So I'm going to count up, 1, 2, and I'm going to count my run as 1. Remember, you always draw up and then over. You always count up because that's your rise, and you always count over is your run. And I'm going to put that as a ratio or a fraction. I'm going to simplify that doing 2 divided by 1, math, enter, and it comes out that I end up with the whole number 2. So I'm going to look at this second triangle, and I'm going to count my rise and run of the second triangle, and I'm going to count 1, 2, 3, 4, and I'm going to count over 1, 2, and I get a rise of 4 and a run of 2, and when I put that in my calculator and simplify it, I get 4 divided by 2, math, enter, and it gives me the whole number 2. So even though the two triangles are different sizes, I end up with the same slope. I'm going to demonstrate this even further by taking, and here's one of those crossroads I talk about where the vertical lines and the horizontal lines cross. I'm going to use that point, and then I'm going to draw all the way up to this point. Okay, so if I drew my triangle, my path, like I'm going from my house to my friend's house, I can't go through the yards. I got to turn the corner here and draw over. You notice now this one's much easier to see. I can draw a straight corner angle here that is straight. I know I don't draw too well. All right, so I got my straight corner angle. That's a right angle. That means that this is a right triangle. And any triangle that you draw on here, if the corresponding sides are on the line, and we're going to talk about corresponding sides in a second, it will create a right triangle. So I'm going to count my rise and run on this one. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So my rise over my run, I'm just going to write this over here. My rise was 10. Now I'm going to count across. 1, 2, 3, 4, 5. So my run is 5. 10 over 5, simplified in your calculator. 10 divided by 5, math, enter, enter, is the whole number 2, which is 2 over 1. So it's keeping it as a fraction, okay? So now what I wanted to talk about as far as, so no matter what the size of the triangle, if they are the same side of the triangle is on the line that is drawn on your grid, you will always have the same slope. I could even draw this triangle down here and go this way, even though I don't want you to go this way, but sometimes this is how they show it to you on a picture. They draw it over and up, which I do not like because then that makes you do run over rise, and we know it has to be rise over run. So if I counted that, I'm still, as long as I keep it straight, my run is 1, 2, 3, 4, 5. My rise is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and I get 10 over 5, which was the same thing. The tendency when you do this is to put this on top because you count across first. But remember, you've got to get out of bed before you can run. All right? You've got to rise before you run. So no matter where those triangles are, even if they're on opposite sides of the line, if the same side of the triangle is connected to the line, it will have the same slope. When we talk about the same side of the triangle, we're going to get into this much more as we move along and we get into another unit coming up. It's called the Pythagorean theorem. And what that is it's a theorem that says that that the two legs of it, anyway, I don't need to get into that right now, but why I want to talk about that is because in the Pythagorean theorem, these right triangles definitely have names to their sides. And I'm going to kind of highlight these two sides over here. And if you notice, they are the diagonal lines, aren't they? So the right angle connects the two sides of the triangle that are not the diagonal. And when you have, and if I drew from that diagonal, you would see that I would get to that right angle. These are called legs. These are legs of your triangle, and this is your hypotenuse. And you're going to get to know that word really well. So, but we need to just understand that it's the diagonal because both diagonals are connected to this line that's drawn up here. That is why we get the same slope. So hypotenuse. And how you we've already talked about how you recognize where this right angle is. If I tried to draw a right angle here, you see that it looks like it doesn't look the same, does it? It looks cockeyed, all right? So that means that it is not, okay? And here you can't draw this, and then here it doesn't work. So the only place it's going to work is in this corner, in those two, which then helps you recognize that the hypotenuse or the diagonal side of the triangle is connected to the line. We call the same side of these triangles, and why we call these triangles similar instead of congruent is because the same sides, when, let's answer this question. When the two sloped triangles from above are described as similar triangles, they are described as similar triangles because, and I'm going to put a BC here, when the same sides, and what we are saying there, they are called corresponding sides, and we need to recognize that word. Corresponding sides, that's the correct terminology for the same sides of two triangles are on the same line. They will have the same slope. And we refer to these as similar triangles because they have the same slope, but they are not the same size. Okay? So let's look at example 2. I'm going to give you a second to finish writing that. So when the same sides, the corresponding sides of two triangles are on the same line, they will have the same slope. Let's look at example 2. Okay? Now, they drew these on the exact same side of the line. Remember, they could be drawn on opposite sides of the line, but still the same sides of the triangle are on that line. And I will demonstrate that in just a second, and they will have the same slope. So I have this triangle here, okay, and I have this triangle here, okay, and I can identify my right angle right here and right here, okay. I know I don't draw really straight, but it is a right angle. So I'm going to count my rise over my run. First, I have to identify the line. Is the line negative or positive? Yes, it's negative. So I've got a negative slope. So I'm going to make sure and put my sign there. And I'm going to count my rise, which is 1, 2, over my run, 1, 2, 3. Okay, so I get -2 for my rise, and my run is 3. If I try and simplify that, I will find out that that is still -2 over 3. All right, so then I'm going to look at my second one, and I'm going to count my rise, 1, 2, 3, 4. And I'm going to count my run, 1, 2, 3, 4, 5, 6. It is still a negative line, so I have a negative slope. I get 4 for my rise, 6 for my run, and when I simplify 4 and 6, I put -4 divided by 6 in my calculator, hit math, enter, enter. I get -2/3. Thus, these are similar triangles. They have the same slope. Okay, so are these similar triangles? Yes. Why or why not? Because they have the same slope. Okay, and there again, if I was to draw a triangle from here, let's say to, let's see, where else could I make that meet? I could draw it from here, and I could draw it, let's see, this one's not really crossing. It doesn't really cross again until here. So I could go like this and draw this triangle. Okay. Here's my right angle. So if I counted my rise, I would count 1, 2, 3, 4, 5. And my run is 1, 2, 3, 4, 5, 6. Uh-oh, something's not working here. What did I do wrong? 1, 2, 3, 4, 5. Something's not working. What did I do wrong, people? Um, 1, 2, 3, 4, 5, 6, 7. Me no like this. It is not working. It should work. Because 5/7 isn't going to give me 2/3. So let's do it this way. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 7/10 isn't going to simplify either. Well, forget that example, but it does work when they're on opposite sides. We proved it over here. Something's wrong with that little situation there. All right, so here is what it looks like for an assessment. Okay? Triangles RST, they mean the triangle that includes the point RST. And TUV, they mean TUV. are similar right triangles. Which proportion can be used to show that the slope of RT is equal to the slope of TV? So what all they're wanting you to do is find the two slopes. Now remember, I'm going to first check. First thing I want you to do is you are going to need to test this and test this. So what I'm going to do is put RT on this side, and I'm going to put TV on this side. Whatever one they list in their question, they will always put first in the answer choice. So in other words, all the answers on this side are RT, and all the answers on this side are TV. Okay? So, first thing I need to do, is this a negative or positive line? Yes, it's a negative line. So, I'm going to write rise over run and remind myself that it is a negative line. Here, I've got rise over run, and it has to be a negative slope. Next thing I'm going to do, I'm going to look at my intervals. Now, I've never seen a triangle problem where they weren't by ones, but I still say you need to check your intervals. How much is each horizontal line worth? How much is each vertical line worth? And you look at your axis for that. Obviously, it's moving by ones on the horizontal. It's moving by ones on the vertical. So I've got ones and ones. All right? So if I count my rise over my run, and this is where when they're upside down like this, it's very easy to do the opposite. I'm going to start right here on the corner, and I'm going to count 1, 2, 3, because that's my rise for R, S. My run is 1, 2, 3, 4. So I've got a negative 3 over 4 for RS, or RT, okay? So this side has to be a negative 3 over 4. Let's look at this side, what it says. I've got my rise is here, U to T. 1, 2, 3, 4, 5, 6. Okay? So my rise is 6. Across is 1, 2, 3, 4, 5, 6, 7, 8. It's still negative, so it's negative 6 over 8. So my TV, I'm going to write over here as negative 6 over 8. I'm not going to simplify that because that is how they're going to give it to me here. Because what they're wanting you to do, yes, it would simplify. If I went and hit that in my calculator, it would eat negative 3 over 4. And I know that they're on the same side, on the same line, because if you notice up here, here's your right angle for this triangle. Here's your right angle for this triangle. Okay? So now I have to go through and put these in my calculator. All right? I need to put these in my calculator and calculate them to see if they match these two that are right here. So the first one I'm going to do is 2 subtract negative 1, enter. And I get a 3. Hey, this is looking good. Okay? Then I'm going to do 5 subtract negative 5. And what do I get? 10. I'm going to do this. I'm going to put 3 divided by 10, hit math, enter, enter. Does that simplify to negative 3 over 4? No, it doesn't. So I'm pretty sure that this one's not going to work. Okay? I don't even need to go on because this is going to have to match this. This is going to have to match this. Let's try the next one. B. 2 subtract 5 gives me negative 3. And negative 1 subtract negative 5 gives me 4. Hey, good so far. Let's see what the other one gives us. Negative 4 subtract 2, and I get negative 6. Ooh, this is looking good. And 7 subtract negative 1, and I get 8. So this matches this, This matches this. Therefore, B is my answer. Now, I'm going to show you the different things they'll do. All right, just so that we can make sure that the other ones, but when you find your answer, make sure if you get two negatives, like a -3 over -4, that you check and put that in your calculator because it's going to change it to a positive. So make sure you're always checking to see if they will simplify. Okay, I don't expect you to go on once you've found the answer, as long as you are assured the answer. I'm doing these down here just to show you the things that they will do. Do you see how they turned this around? It's the opposite upside down of that. Okay, so that wouldn't work. Here they've got 1, subtract, negative. Oh, I'm sorry, it's not that. It's -1, subtract -2, and you end up with 1, and you end up with -5, subtract 5, and you end up with -10. A lot of times they'll give you the answer in, that's not it. They'll give you one of them that looks like this. And if you were to simplify and make sure -3, -3 divided by -4, you would think that that's the answer because you see a negative sign there. But really, that's going to give you is, if you simplify that in your calculator, it will give you +3/4, which wouldn't match RT. So this is the type of practice you're going to see today, and that's what you need to do. This is the type of questions that you're asked on an assessment. Have a great day. I hope you guys are behaving yourselves, and I will see you tomorrow.